Hello people, so in that video we're gonna deal with how to detect that the movement is done in the area you're interested in. So to do so, we need to get the pixel data of the shape, for example a red shape, analyze it and see if there's some significant movement in it, then we'll return something. So let's go back to Sublime here. Once this is drawn, when the static shapes are drawn, we will need to loop over it again. So I can just copy that. We're gonna loop on that object, and as we did in the previous video, we have these key values, and instead of drawing it, we'll have to get the pixel data out. So how do we get the pixel data? You create a variable, and on the context you get this function we used before, get image data. Image data, and you have to provide the shape you want. So in that case, it's the object values we're looping on. So that way we're going to have like 4 object data, and that corresponds to the 4 shapes. We can console log it. Let's see, but let's reduce that interval. Expected token 53. Why is that? And so shape key. Oh, all right. Close that. So let's see. For every 2 seconds we get 4 objects, so corresponding to the 4 areas we have. And if we open, for example, this one, then we have the specific height and width of that shape and the pixel data out of it. So here you have. So that's it. Now we have the pixel data of all the shapes. We simply need to detect if in each of the data objects of the image data objects, the 3 first pixel values from the RGBA model do have some significant change compared to the previous frame. So basically, if you open any of these data objects here, we need to make an average of all the 3 first values. We ignore this because it's the opacity. We sum all this, we make an average, and if the average on all the data set is bigger than a threshold, then we can consider there's a movement in that area. So we're already looping on it. So we need to calculate an average, basically. So we'll create 2 variables, I and an average. We're going to loop on that area. So it has to be until the length of that specific area. So it's going to be area.data, because the length, it's the length of the data object inside the image data. So we have to loop until that length. So to do this, because we do it every 4 values, because it's the RGBA model, we divide it by 4. And then we have to calculate the average of area.data, and then we have to provide for I, and then let's copy that, and this is +1, this is +2, and we increment this. So in the first place, I will be 0, so that would be 0, so it would be the first value of the array of the data object. Then this would be 1, so second value, third value, and then once we get at 1, this would be the fourth value. So in that way, we ignore always the opacity value, meaning the fourth value. So we take first, second, third, and then the fourth, fifth, sixth. We're going to make an average of that. So we have to divide it by 3. All right. Yes, we need to plus equal this. That should do it. Let's console log the average. Let's maybe not console log this anymore. It would be too heavy for my Mac. Okay, so we got the average here. That's big. See, you can see already that if you move in the yellow shape, which is the last of the 4 values the browser is giving, if I move in the yellow one, the average is bigger. See, it's 89 instead of 20 something. But what I need to do is, so this average must be this should be equal to average divided by area.data.length divided by 4. If I'm not mistaken. Some parentheses here. Because I get a very big value because it's the average of all the 3 first values averaged, but on all the data array. So I need to divide it by the length of that area, of that array, and by 4. So that should be better. Yes. So now I got an average that is more accurate because it's a true average of all, a true average of all the data array. So I can map around that. So it looks a little less ugly. All right. So let's see. Let's show at the same time the key, so we can key average. So that should variables. That should work. Okay, so now I see the average corresponding to the area I'm looking at. So this is every 2 seconds, but we can see already that the red, the value is very small, 5, the blue also, because I'm not moving in this area. I'm moving more on the yellow and a bit on the green, and you see that the yellow average value is bigger than the other ones, and the green is slightly higher as well. So let's do it real time. So here you see, yeah, you see the same values. So basically here I'm moving on the yellow. I should only display yellow starting from a certain threshold. I'm not moving on the red and blue, but you see there's still some pixel change in that, because even if there's no movement, there's always a little bit of movement, no? And the average of the pixel data modification, well, it's very low, but it's still there. So we can consider movement only after a certain threshold, and we can see here that yeah, the yellow, I'm definitely moving there, and the amount of change in that area is a bit higher than 10. So what I can do is, if the average is higher than let's say 15, we're gonna console log it. So nothing is logged and only yellow is logged. If I move here, now I get red display and a bit yellow also. If I move here, I get blue. If I move here, green. All right. So we got it. We got movement detection in front of our camera. So I move in the red and blue, and it's displaying red and blue. What we only need to do now is, instead of console log it, we'll be sending commands to the drone. So that is controlled by movement recognition. But that will be in a further video. I will make 4 or 5 videos regarding the backend in the future. But in the meantime, yes, that was easy. You just simply need to loop on that, get the image data of the area you're interested in, and then you need to average all the pixel data modification that you have. Meaning, I mean, the difference in the pixel data is already made here, right? And you simply average it and see if it's significant, and then if it is significant, then we have this comment that we need to send at some point. Okay, I hope you liked it. It's done from the front. In the next video, I'll start doing the Node app for the backend, and show you how, with some Socket.io package, you can send some command to the drone and connect it to the front end. Thanks for watching. Bye.